The criteria for rating flexible cords for extra hard service versus hard service is defined in UL 66, Flexible Cords and Cables. Extra hard service cords are designed for use in locations where they will be subjected to severe mechanical abuse, such as in industrial settings. These cords must meet the following requirements. Firstly, they must be able to withstand a minimum of 250,000 flick cycles without failure. Secondly, they must have a minimum insulation thickness of 0.30 inches. Thirdly, they must be resistant to oil, moisture, and abrasion. Hard service cords are designed for use in locations where they will be subjected to moderate mechanical abuse, such as in commercial or residential settings. These cords must meet the following requirements. Firstly, they must be able to withstand a minimum of 100,000 flick cycles without failure. Secondly, they must have a minimum insulation thickness of 0.25 inches. Thirdly, they must be resistant to oil and moisture. The distinction between extra hard service and hard service cords is important because it ensures that the cords are used in the appropriate applications. Using an extra hard service cord in a hard service application may result in premature failure of the cord, while using a hard service cord in an extra hard service application may pose a safety hazard. Flexible cords are used to connect electrical devices to a power source. They are typically made of stranded copper conductors insulated with a flexible material such as rubber or plastic. Flexible cords are available in a variety of sizes and types to meet the needs of different applications. The National Electrical Code, or NEC, provides requirements for the use of flexible cords. These requirements are intended to ensure that flexible cords are used safely and that they do not pose a fire or shock hazard. Flexible cords are classified according to their intended use. The two main classifications are hard service and extra hard service. Hard service cords are designed for use in applications where they will be subject to moderate mechanical abuse. Extra hard service cords are designed for use in applications where they will be subject to severe mechanical abuse. The type of flexible cord that is required for a particular application depends on the severity of the mechanical abuse to which the cord will be subjected. For example, a flexible cord that is used to connect a portable tool in a factory will need to be extra hard service, while a flexible cord that is used to connect a lamp in a home may only need to be hard service. The NEC specifies the types of flexible cords that are permitted for use in different applications. The NEC also specifies the minimum size of the conductors in flexible cords. The size of the conductors must be sufficient to carry the current that the cord will be carrying. The NEC also specifies the type of insulation that is required for flexible cords. The insulation must be suitable for the environment in which the cord will be used. Flexible cords must be properly installed to ensure that they are safe. The NEC provides requirements for the installation of flexible cords. These requirements are intended to prevent the cords from being damaged or from posing a fire or shock hazard. Flexible cords should be inspected regularly to ensure that they are in good condition. Damaged flexible cord should be replaced immediately. When selecting a flexible cord, it is important to consider the application for which the cord will be used. The cord must be rated for the voltage and current that it will be carrying. The cord must also be suitable for the environment in which it will be used. Extra hard service flexible cords are designed for use in industrial and commercial applications where they are subject to heavy use and potential damage. These cords are typically made with heavier gauge wire and thicker insulation than hard service cords. They are also more resistant to abrasion, oil, and chemicals. Hard service flexible cords are designed for use in residential and light commercial applications where they are not subject to the same level of abuse as extra hard service cords. These cords are typically made with lighter gauge wire and thinner insulation than extra hard service cords. They are also less resistant to abrasion, oil, and chemicals. The choice between extra hard service and hard service flexible cords depends on the application. If the cord will be subject to heavy use and potential damage, then an extra hard service cord should be selected. If the cord will only be subject to light use, then a hard service cord may be sufficient. UL 66 provides the specific requirements for flexible cords. It details the construction, testing, and marking requirements for these cords, ensuring they meet safety and performance standards. Understanding UL66 is crucial for manufacturers, installers, and users of flexible cords to ensure they are using the correct cord for the intended application and that it meets the necessary safety requirements. The flex cycle test is a critical aspect of UL66. It simulates the bending and twisting that flexible cords experience during normal use. Cords that pass the flex cycle test are more likely to withstand the rigors of daily use and last longer. The minimum insulation thickness is another important requirement of UL66. The insulation protects the conductors from damage and helps to prevent electrical shock. Cords with thicker insulation are more resistant to damage and provide a higher level of safety. The resistance to oil, moisture, and abrasion is also important for flexible cords, especially those used in industrial and commercial applications. Cords that are resistant to these elements are less likely to degrade and fail, which can lead to safety hazard. When selecting a flexible cord, it is important to consider the environment in which it will be used. If the cord will be exposed to oil, moisture, or abrasion, then a cord that is resistant to these elements should be selected. Flexible cords are available in a variety of types, each with its own specific properties. Some of the most common types of flexible cords include Type S, Type SO, Type SJ, Type SJO, Type SV, and Type SVO. Type S cords are general-purpose cords that are suitable for use in a variety of applications. Type SO cords are oil-resistant cords that are suitable for use in applications where they will be exposed to oil. Type SJ cords are junior service cords that are suitable for use in light-duty applications. Type SJO cords are oil-resistant junior service cords that are suitable for use in light-duty applications where they will be exposed to oil. Type SV cords are vacuum cleaner cords that are suitable for use in vacuum cleaners. Type SVO cords are oil-resistant vacuum cleaner cords that are suitable for use in vacuum cleaners where they will be exposed to oil. When selecting a flexible cord, it is important to choose a cord that is the correct size for the application. The size of the cord is determined by the amount of current that it will be carrying. If the cord is too small, it will overheat and could cause a fire. The NEC provides tables that specify the correct size of flexible cord for different applications. Flexible cords should be inspected regularly for damage. Damaged cords should be replaced immediately. Do not use flexible cords that are frayed, cracked, or otherwise damaged. Flexible cords should be stored properly when not in use. Do not store flexible cords in a place where they will be exposed to moisture or extreme temperatures. Flexible cords should be handled carefully to avoid damage. Do not pull or kink flexible cords. Flexible cords should be used only for their intended purpose. Do not use flexible cords to connect appliances that are not designed to be used with flexible cords. Understanding the criteria for rating flexible cords, especially the distinction between extra hard service and hard service as defined in UL66, is essential for ensuring electrical safety and preventing equipment failure. By considering factors like flex cycles, insulation thickness, and resistance to environmental elements, one can select the appropriate cord for a specific application, ultimately promoting a safer and more reliable electrical system.